This video is about advanced graphs and specifically about the truncus. So if you're watching this video, I'm assuming you've watched the video on hyperbolas, and I'm not going to go through this one as thoroughly as I did with the hyperbolas because a lot of the concepts are the same. And if you watch the hyperbolas video, hopefully you'll understand why the shape of the truncus is what it is, based on the definitions and explanations in the hyperbola video. So you'll notice that I'm working off the summary again. So the hyperbola stuff's up here. Hyperbola was y equals 1 over x, the basic hyperbola. This time all we're doing is adding a 2 onto the x, so a squared. So I spoke in the last video about these graphs being x to the power of -1, x to the power of -2, and x to the power of a half. The hyperbola is x to the power of -1, which is 1 over x. The truncus that we're doing in this video is x to the power of -2, which is x to the power 1 over x to the power of 2, or 1 over x squared. So, and the next video will be x to the power of a half. So we're dealing with 1 over x squared. Now the same rules apply to the truncus as did the hyperbola in terms of asymptotes, because we still can't have a 0 on the bottom, hence the vertical asymptote at x equals 0, and the whole thing can never equal 0, just like the hyperbola. So therefore we have an asymptote along the x-axis at y equals 0. Just the same explanation as in the hyperbola video. So hopefully that makes sense and I don't have to go through that again. The only real difference here is that we no longer have the left-hand portion of the graph down here. And that's because of the squared. Because what a squared does, the impact a squared has on a graph is, an x squared specifically, is when we put in values that are positive, they stay positive, they just get bigger or smaller quicker. But when we put in negative values for x, they become positive and bigger or smaller quicker. In other words, if we put -3 in here, we'll get a +9. Whereas in the hyperbola, if we put in a -3, it would stay as a -3. If we put in a -1/4, it would become +1/16. Therefore, overall, 1 over a +1/16 would become 16. So the values get positive from negative, whereas in hyperbola they stay negative, and they get bigger or smaller much quicker. So hence the shape here. And what I'll do on the calculator here is show you what happens when we graph them at the same time. So 1 over x looks like this, and 1 over x squared looks like this. So you can see here that these crossover points, I might actually put, nope, that's not what I want to do. I might actually put these points in. So I'm just using a technique that I've shown, oops, that's not what I want to do, that I've shown in previous videos. So I'm just putting the point 1, 1 in there, and I also want to put the point -1, -1 in there. And I've accidentally put in an extra point, so we'll get rid of that. So the point, oh sorry, I'll do one more point because we want it on the other graph as well. So I want to put this point in. Okay, so I've put in the point 1, 1, which actually exists on both graphs. -1, -1 here, and -1, 1 on this graph. So you can see here that that's the only point that they share, these two graphs. And then what happens is as we get large in terms of x values, the truncus, which is the red one, is getting smaller quicker. And then as we get small values of x, the truncus gets bigger quicker, the red one. Whereas the blue one gets smaller less quickly and gets gets bigger less quickly here and gets smaller less quickly here. So that's the difference if you graph them together. All right, so looking at the general equation, it looks very similar to how the general equation of a hyperbola looked, but this time we have a squared there. So y equals a over x minus h squared plus k. Now, A still covers dilation and reflection, H is still our horizontal translation, and K is still our vertical translation. We still look for the vertical asymptote, which is x equals h. We still look for the horizontal asymptote, which is y equals k. And we still look for the y-intercept by making x equals 0. It's all the same. We still look for the x-intercept by making y equals 0 and work backwards. So in terms of graphing and finding out all the important bits of a truncus, it's all exactly the same as how we did it for hyperbola, except we've got a squared to manage when we're working backwards. Now, because of that squared, when we're working backwards, we would have to square root the other side using that plus and minus symbol that you would have come across in quadratics and quartics. Also, you can see here, unlike a hyperbola, where as long as k wasn't 0, there would be x-intercepts. If k is 0 here, there's no x-intercepts, but if k is positive and the graph is upright like this, it's going to move the graph up, which means there'll be no x-intercepts. And the same thing is if it's flipped and moved down, there'll be no x-intercepts. In other words, if A and K are the same sign, there's no x-intercepts. So that's the same for a quartic, a quadratic, and a truncus. Okay, so that's something you can check along the way. If A and K are the same sign, there's no x-intercepts. So I'm going to get stuck into this example. I'll write it down on the iPad and then I'll switch the screen over so you can see what I'm doing. So we're going to graph this one here. So first step, we want to find, now we're just following along here, so the first step was the vertical asymptote. So vertical asymptote at x equals h, in other words, in this case, -2. Remember, it's the opposite sign of what's going on in there. I'll just start a little bit more to the left so we've got a bit more room. So vertical asymptote at x equals -2. So then we look for a horizontal asymptote, which is at y equals k. So that's y equals 1. So there's our vertical asymptote, there's our horizontal asymptote. The next thing we do is look for a y-intercept by making x equals 0. We're making x equals 0. So 0 plus 2 is 2, 2 squared is 4, and 1 can be the same as 4 on 4. So we end up with 5 over 4 as the y-intercept. So the y-intercept is 0, 5 over 4. I'll just get rid of the working out. So the next thing we want to do is look for an x-intercept, and we make y equals 0 and work backwards. But remember that little hint, if A and K are the same sign, there are no x-intercepts. So A is positive 1, K is positive, so they're both positive, therefore no x-intercepts. And we can just write in the working out no x-intercepts, and you can even write A and K same sign if you want to. That's perfectly fine working out, or you can just say no x-intercepts. So then it comes to graphing. Vertical asymptote at x equals -2. Horizontal asymptote at y equals 1. We have a y-intercept of 0 and 5 on 4. Now 5 on 4 is 1 1/4, so it's just above 1, and then our graph. Now remember, we don't want to touch or cross that line. We also don't want to bend up at the end like we did with hyperbolas, and we also want to make sure that there's balance either side of the asymptote. So my graph looks pretty balanced. It's probably a bit wider here than it is here, so let's fix that up. And you want to be careful with this. You don't want to rush it. You don't want to be uncaring or a bit dismissive about getting this right. You actually want to graph it really well. So I want to make sure the same distance there as there, so it looks a bit like that. That looks pretty balanced. Now, on here we've only indicated 1 point. We haven't shown 2 points, so it might be good to find another point. Now, I like to create a bit of balance here. So when x is -2 is in the middle, and then I've got my y-intercept obviously at x equals 0, the balance point will be at x equals -4. So I know, because of symmetry, that that point there is going to be -4, 5 on 4. It's going to have the same y value as the y-intercept. because it's the same distance away from the asymptote as the y-intercept. We can show that by subbing in -4. So -4 plus 2 squared plus 1. -4 plus 2 is -2. -2 squared is 4. So we get the same thing as we did when we were working out the y-intercept. So there's a bit of symmetry. There's a lot of symmetry in truncuses or trunci. I'm not really ever sure which one it is. In a truncus, there's symmetry. So we can actually just find the balance point over the other side. Okay? So that gives you a bit of balance there, and it also makes sure you're always labeling at least 2 points. So if there's a y-intercept and an x-intercept, you probably don't need to label any other points, but if there's only one of those, then label another point as well. And that's a truncus. Now with hyperbolas, there was another way that it could be represented. With truncuses, we don't have to deal with another way of being represented. So that's basically all you do with truncuses. So practice, get used to graphing them, finding the asymptotes, and there's another depiction of that example that I gave over here. Okay, so if you need that working out, it is there. Next video will be on square root graphs, which is x to the power of 1/2. But in the meantime, practice truncuses and let me know if you need any help.